Now I'm very happy to introduce our next speaker, which is Casper Kofod from Denmark. Casper will go through our study and his work on smart lighting. And well, it's Casper that's been the main task leader of this, but again, it's collective work by all the experts. And the report was published about a year ago. We've run a seminar or two actually tandem seminars on this report, but it's a very, very interesting and very quickly evolving topic with a lot of new data coming in, a lot of new products being developed, and always new things to address. But Casper, please.
Thank you, Niels. This presentation follows very good in the line of Christophe's presentation, because we are speaking about circadian lighting and dark nights, bright days, and so on. All these things we can get by smart lighting. And it's a pleasure for me to be here today to give a presentation for you. And let's see. The agenda for my presentation will first be to talk a little about smart lighting, which is developing all the time to include more and more features and becoming also more and more complex. And you can store a lot of data, collect a lot of data if you will want to do that. And this is somehow used as a for the commercial aspect, used for as a benefits in sales of these products, but so far we have not seen that all these big data have really been used. But it's normal. We also see that in other sectors. It's not easy to get the maximum value out of millions of data. But let's see in the future. Then there will be something about trends and what's happening in the markets and what barriers do we still have to get very successful within this area. We will look at including controls more, and the topic just from before, human-centric lighting, circadian lighting, as Christophe told us about. And then we will come, as Niels said, to our second report, which came in November 2022. Some highlights from that, and then some results from studies we have done after that, where we have done detailed studies on dimming and changing color temperature and looking at performance of the lighting sources when we do that. And finally, recommendations to our stakeholders when we do all this work in IEA. Of course, it's for our governments primarily, but also for all the population in our countries and hopefully the rest of the world. If we look here at this complicated figure I made, the basic thing is within the light green area. That's where it started about nearly 15 years ago, that we had the LED technology coming in, and we had the wireless technology coming in smartphones and other devices. So these two things made that we could make wireless control of LEDs and have smartness when it comes to dimming, color tuning, making scenarios in the morning where the lighting is gradually changed, or in the evening, or when you have a party or whatever. Then there's been adding things like using camera or using having music from the lamp, and a lot of other things which can be combined in with these smart lamps. We have, as I mentioned before, possibilities of storing data and getting use of these monitored data. And we have a lot also on the network side, but so much for that for the moment here. Connected lighting, I should also mention that it can be used in museums and shopping, for instance, where you use the lighting network with the Wi-Fi nodes for navigation. And when you stand in a shop, that you can get information or in a museum actually about the things you are looking at. What we are analyzing in our IEA work is that we look at the standby power, which is the cost of having all this smartness, because the lamps are on all the time. So it takes a standby consumption. There's also a few other things like gateway for some of the products, which are also on all the time. But standby is the main thing. We look at the color quality and the efficacy when we do these smartness things, and the flicker, as we already heard about. What influence does it have on the flicker when we do dimming, for instance? Smart lighting is gaining ground. Especially during the COVID, there was a lot of sales of smart lighting, more than now, because people were at home and were interested in doing something at home and got a look at, oh, I could use smart lighting for things in the home. It's primary comfort things we are buying for today. Some may say, yeah, you can do a lot of energy saving, but they are not really designed to help you doing this. You know that you should get some savings by dimming, but sometimes it has a price, as you will see later on the efficacy. So how much are you really gaining? That's the question for some of the products. In the commercial sector, the health, the hospital sector have been gaining by smart lighting. It's used and it have good results. People can come home for the hospital earlier if they lie in the hospital where they don't have direct access to outdoor lighting. It has an effect on helping people to recover. And I would say I expect this could also come into offices in the future much more. Barriers are that some of the products are still rather expensive. Others are down at a level where they are affordable for most people and you can buy more than a few, but more is expected to happen within that. Then we have software which is too complicated to use when you set up, when you're going to install. But the manufacturers are aware of that now. They make simplification and make plug and play concepts. So something is happening there. In the commercial sector, we also had the problem with a lot of systems already, which were with wired communication, primarily daily control. And then we come with another system, which is wireless. So two systems, but within the last year, there's come through the daily association several gateways now, so you can combine systems. That's a big step forward. Then the standards, which always come a little later than the development of the products, we still are lacking some things there in the standards, but it's coming. Potential could be much larger, for instance, in the domestic sector, if we had more products with movement and daylight sensors included. So we could control like we do in the commercial sector in our homes, then we could save more energy. And also daylight sensors could be used more in the commercial area and offices. As mentioned, this report came out in 1.5 years ago. And the content is that we are looking into key terms of smart lighting, defining some where we needed some extra and listing them, looking at different protocols used in the communication and network architectures, which are different. And this does that when people buy from different manufacturers, you often have to control them by different systems. This is not smart. We need interoperability for the users. So you're not stuck with one system, but you can use products from many manufacturers. We've been looking into that. We have also been looking into test methods because something were missing for the smart lighting tests. And we have been using that to do testing around for the last 10 years. And you will see some results with the next slides from that. And looking at the saving potential by reducing the standby consumption and a few other things. And finally, our recommendations. The test methods are building on the measurement standards we have already for, let's say, normal lighting sources. And I will not go into details about that, what we do, but we came with some suggestions of how many stages you should measure in, but it's expensive to measure in many stages, so it's a balance to do that. But as you will see later in my presentation, it is necessary to do some measurements in stages if you want to be sure about you make savings. In this slide, you see standby power for 236 lighting products within 10 years. We have the lowest values, which came rather early, of 0.08 watts, very low and desirable. And we have others which are up to 3.5 watts. The average is about 0.5. And this is where the regulation have come to be in EU and in Energy Star in USA and in Australia, New Zealand. But you don't see a big improvement in reducing the standby when you look at this slide. You see that the major part is lying under 0.5, but also many are up in the area to 1. And then we have outliers much higher up, which some of them were first generation products which are improved later. Others have cameras or music from the lamp or Wi-Fi boosting of the signal. So these things also take consumption. If we look at California, USA, they were the first place where they did regulation on the standby, or they did it already in 2019. And they set the border at only 0.2. And at the moment I was looking at products there, and it's even better now when I look. There were more than 500 products which are certified and have standby under. So it's possible, and it's all the product we also see in Europe for sales. So this shows it's possible to come down at that level. It's a question about the electronics you are using when you make your lamps. Then we tried to look at Energy Star, and which is used in USA and Canada, and the certified products for Energy Star. And here we found that 81% of these lamps are also under 0.2. That shows that what happened in California has spread because it's a kind of common market over there. So difficult to separate products only for California and others for the rest. So it's very positive what happened over there. They are much better than anywhere else in the world on reducing the standby. Now I was speaking about electronics before, but another way to get the standby down is that you could use 2 radio receivers. When you look for a signal, somebody wants to contact the lamp by the mobile phone or something else, then there has to be a receiver. If there's a receiver only looking for a signal, it takes very little power. And when there comes a signal wanting to contact, then it could wake up the main radio, which take more power. By doing that, for instance, you have a wake up 2 milliseconds out of 100, then you reduce by a factor 50. This concept was developed by IEEE for battery-driven appliances, but it can be used here, and some manufacturers are actually using it today to reduce the standby. Then people could ask, does it matter 0.5, 0.2 watt? It's not much. it becomes much because the effect of the lamps are going down. They're getting more and more efficient. So if you compare to that, it's getting up, but it's also making a lot of energy consumption when we have millions or even billions of smart lamps around the world. And I've been calculating on two cases, a directional lamp providing 360 lumen and non-directional providing 806 lumen. And you can see if standby is 0.5, 0.2, or 0.1, or even 0.01, what happens in case these lamps are used in the domestic sector where the typical average use over the year per day is 1 hour or 2 hours. And you can see by these percentages that the standby consumption is not something we have to worry much about when we come down at 0.01 watt. But until that level, it still makes sense to do something. As if we look at 0.1, it's 43% in one case, 27% of the total consumption in another case, and 26 and 14 in the last one with 2 hours of use per day. So it's a big part, and if in the worst case it's half of the consumption which is used for standby. Gateways, which are used for some of the projects, because you could use a simple protocol between the lamps, like Zigbee, and then you could use Wi-Fi after the gateway, which take a little more consumption. But these gateways, they take energy, and they can take care of 20 lamps, but many people don't have 20 lamps, they have a few. And if you look at the columns there, the green one is the part of the total consumption which go to the gateway. And for 1 and 2, 3, it's a large part of the consumption. The trend is now that the gateways are on way to go out of the markets, and we have only one protocol in use, Wi-Fi, or yeah, few others. Now we come to my last point before recommendations, and that's we were looking more detailed and measuring more detailed on dimming and changing color temperature. What happens when we do that? The first one, we can look at some domestic lighting sources and look at the efficacy. And we found here that the products did fall into a cluster of 5 groups. And the first group actually improved the efficacy a little with dimming. And the next one was stable, which you would like to have when you buy a product, because you would think you would get the same, no matter how much you dim, you would have the same efficacy. But then it starts to go down, and the last 2 groups, they are, it's 24% of the products. There's nearly no energy saving by dimming, because the efficacy goes down. And you don't know that when you buy the product, because nothing is specified about what happens with the efficacy when you dim. If we look at the luminous flux, you have here some groups I've highlighted, and if you look at changing the color temperature, you see one group to the very right where it's stable. So it's easy to use, it's good for the customer. But you see another group earlier up 7 to 10, where it's very much dependent on which color temperature you choose, what you get. And the same with the efficacy. It has different forms. Some of them increase, some of them are flat, which would be the optimal for the customer side to understand. And some of them go like a bow with the highest efficacy around typically 4,000 Kelvin. If we are looking at stroboscopic visibility measure, SVM, we found that nearly half of them have problems when you are dimming, that it's too high in the lower dimming areas. And it goes both for commercial use to luminaires lamps and domestic lamps and luminaires. This is a problem because designers, they would look at the efficacy of the lamps when they are used with no dimming. And sometimes they know what color temperature the efficacy is for when they see lumen output and they see the power used. But sometimes you don't know that, but it might be different if you start to use the smart facilities. And you don't know that when you buy the product, except there will be more information to the customer. And the same with the flicker. There might be flicker when you dim. So there's a need for characterization of the lamps, or else some customers who buy the products with problems will say, it's not good lighting these lamps are giving. They don't know actually what the problem is. They just can get the impression it's not good lighting, I see. We are trying actually now in the revision of CIE S025 to get them to include something about characterization of the lighting, of smart lighting. And one of Carsten's colleagues are in this group, and we hope we can get them to do something about this. So the manufacturer have to give some more information. There's a few now who have started to give information about two color temperatures. That's one step forward if you have that, a warm and a cold temperature. But there's need for more than that. And also for the data files you get today for design and simulation, they are only designed for one setting. So there also have to be a change of the way to exchange data and the software for this. And summing up, our recommendations are that with the next revision of the regulation, we hope everyone like California could come down at 0.2 because it's shown it's possible to do that, and then put in also in the regulation a lower goal. If it's 0.01 or 0.05 or but something which is a future goal. Actually, we don't have a future goal in the regulation. And also it would be nice to do something about the gateway and encourage the manufacturers to use the wake up radio concept if they say it's difficult for them. When you have many features within the smart lights, it's often also not possible to switch off some of the smart features. And that means when you measure the standby, it could be a sum of several standbys. And here we recommend it's possible to switch off the different features in the lamp. Characterization I already spoken about, but we say one possibility could be to do like we have been doing on our measurement, that we had 4 levels of dimming and we had 5 color temperatures. But we are aware of it takes time to measure for 20 stages instead of only 1. And finally, it would be good to focus more on energy saving and not smartness for having more comfort or something to show off with. I think my time is gone and I'm finalized my presentation now. Thank you.
Brilliant. Thank you very much, Casper. So do we have any questions? You have 2 online. Do we have any questions from the floor here? Okay. Mike?
Okay.
take from
Oh, we now have three. So first question, Casper, sorry. California, of course, uses lower mains power than Europe. How does the mains voltage affect standby power?
That's a hard question to answer to right now. For me, I would say, I don't know, Steve, do you have any? No, Steve shaking his head.
Okay, there are two experts here in the audience from the SSL Annex or the SSLC platform. Neither of them think it does affect because it's a conversion of the driver. But I'm not so.
I better not say anything before I'm quite sure on everything.
Certainly,
So I think we will keep the question and come back to it.
We'll come back to that question.
Yeah.
Next question, can the IEEE wake up radio concept be used if the California Title 22 requires a 0.5 second or half second response time? I think the IEEE radio wake up is faster than that.
Yeah, it's much faster than that. So I wonder what is behind the question when it's raised like that. They go down at milliseconds in the wake up call concept, as I explained earlier with the slides. So okay, it's kind of misunderstanding. I don't know. I try to figure out why this.
Do you want to hop back to that slide, Casper?
Yeah,
just to see
go back.
for the person online, maybe they missed that point in your talk. There.
Oh, yeah, yep. We had it. The example here is a wake up of 2 milliseconds every 100 milliseconds. So it's much lower values we are speaking about. And this is what is implemented for battery-driven appliances and manufacturers who have told me they've implemented them. I don't know exactly their values. I would be interested to know that, but they didn't tell when we talked about it. They just informed we are using it and we have low values now on that. And
yeah, and of course, a second is 500 milliseconds.
Yeah.
So it can happen 5 times before. Yeah. Okay. Let's go next question. The recommendations, how are they enforceable in practice, knowing the limited resources and possibly knowledge of the market surveillance authorities, especially in Europe? How are the recommendations enforceable?
The question is about, as I said, if we would do with 4 levels of dimming and 5 on the color temperature, that will be 20 stages instead of 1 we have to control when we do the market surveillance. So of course it will be more expensive for the energy agencies. And I'm looking down at Peter, but he's very busy down there. Peter, we are talking about when you do your market surveillance of smart lamps. If we do a characterization with 5 levels of CCT and 4 of dimming, it will be 20 times the amount of work. How do you look at this? It will be more expensive to do. This is our question.
Nils, could you pass the mic to Peter?
Sorry.
As you say, it's a matter of time. It's not difficult to do, of course. It's just that it will take 5 times the time. So it depends on the volume of lamps we will test. It will affect the cost. We have the fortune to have our own lab in-house, but maybe if you hire a commercial lab, that will be seen as a burden that you are not willing to take.
And I would say we have been doing it for between 30 and 40 lamps in Denmark. And when you first have the lamp set up, it's not taking the same time to do the setup of the lamp. It's then getting more efficient to do the measurements. But of course, it takes some extra time for every stage you you want to measure.
But having said that, I can agree with you. If it's a real problem, we should nevertheless regulate it. So in principle, we can check. We might choose just the standard setting, but we can check if we find it important.
But it is more work both for the manufacturer and for the energy agencies who do the market surveillance. That's clear. But as long as we have products where we have this problem, we have to do something about the problem. Else the customer have the problem and say we don't get good lighting, so we have to address it.
Okay, I think we have no more online questions, but if that case, you'll have to go in and maybe chat the answer later on. But it was all the online questions anyway. So thanks a lot, Casper.